Yeah, okay. So let's go through it together, and then maybe you can go through it alone much more at your pace. Okay, so in this tutorial, I will present the basic steps of a data science pipeline. So the first one is data exploration and visualization. So this is where we explore the data set and then choose important features, visualize them according to survival and non-survival. Then the data cleaning is the second step. That step involves data cleaning, feature selection, feature engineering. So we're trying to look for null values. We're going to encode categorical data, and then we're going to transform features. So that will be the second step. Then the third step is going to test different classifiers. In this case, since it is a classification problem, we're trying to see, does this person survive or not survive? It is going to be a classification problem. And we're going to use the classifiers different classifiers that we just learned. In this example, we're going to use a logistic regression. We talked very briefly about logistic regression. We're going to use a KNN, k-nearest neighbors. We talked briefly about it. The support vector machine, we also talked briefly about the support vector machine. The naive Bayes, we also talked about that briefly. We did talk about a random forest, but yeah, it's also an example of a classifier. Okay? So let's start by first importing the essential libraries to work with. That's data frames, numerical values, pandas for the data frames, the numerical values is NumPy, and then visualization is they're going to use the Matplotlib pyplot. All right, so I believe you've already been set up with notebooks, you've interacted with a bit of Python, the pandas and the NumPy. So I'm not going to really be syntactically explaining the code. I'm just going to be like giving you the reason for why they're doing every step. So the first step in the notebook is importing these libraries. Okay, so now let's import the CSV file with the training data set. You can download it from here. I'm going to share these resources, so you can also go and download this data set and then follow step by step like how they've done. The explanation of the features, that is each column in the data set, is also presented in the link. Okay, so this is the process of downloading the data set, and in this case the CSV, it's a CSV and its name is train. So the first step, for a good start, we should look at the data set, analyze the features, and think which could be useful to predict the survival rate. So this is the data pre-processing or preparation part that I was talking about. So we look at the data set, we analyze the features that have been given, and then we see, okay, which one is going to be useful to predict the survival rate. So the features that probably may have influence are in the P class. Are the P class, so there's a feature called P class. Expect to see more survival for the higher class, and then there's sex, and then there's age, and then women and children first, let's say also embarked too. All right, so we'll see some plots. We'll now see some graphs to confirm if these features show some relation to survival rate. These features were based in the graphs presented here. Okay, so they're trying to see, okay, we've gotten the data set, it has a bunch of features, and then we want to see, okay, which features are going to be helpful. So for you to determine, okay, that is the feature selection part, for you to determine, okay, which feature has the biggest, like maybe influence on whether a person survives or not. Is it the P class? Is it the sex? Is it the age? Does the age matter if someone is going to survive on the Titanic or not? Does the sex matter if they're female or male for them to be able to survive on the Titanic or not? So this is the process they went through to see which features they're going to use to train their model. Okay, so the first thing they do here, let's see what plots these are. All right. Okay, so they're just trying to understand the data here. So we can see this line of code, they're trying to see, okay, for the people that survived, but are in the P class, how many are they? Okay, so for those that did not survive, okay, so survived being 0, that means they didn't survive. And they're in the P class, how many are they? So they create a data frame called D class, and then it has the people that survived and the people that didn't survive, but they're all of the P class. Okay, so this is just, they're going to use this as a, trying to index. Okay, then they plot this data frame, a bar plot, and it is going to be stacked. And then this is the title. So this is survive or died by the basing on the class. And then, so now this is just trying to get the percentages. So percentage of class 1 that survived. So this is just getting the class 1. Class 1, this is, they get this data frame they just created. And then they, this is trying to select okay, this is row column, the first column, that is the 0th column, then this is the second column, then this is the third column. This is 0, 1, 2, and then they divide this by the total number. Okay, so it looks like the classes are 3 classes, 1, 2, 3 classes that they get. Okay, so this is the whole point. Now, if I was doing it myself, we would have to first see, okay, what does this class look like? All right, so this is just a trying to see, okay, from these classes, 63% of them survived, 40 of class 1 survived, 47% of class 2 survived, 24% of class 3 survived. Yeah, and this is the one that I was looking for, the different classes, the numbers. This is the number of those that survived, the number of those that didn't survive, and the total is this plus that. Okay, so then you come and then just try and illustrate it. So for those that survived, how many belong to which class? So class 1 is blue, green is class 2, class 3 is red. And for those that died, we can see that the biggest percentage of those that died are in class 3, and the biggest percentage of those that survived are either in class 1 or 3. So this is the whole process of trying to explore your data by visualizing it. So you can see already that there's some relationship between surviving or dying just by basing on the class. And you can see how they've broken it down to see that would be probably P class, or the class that you belong in will probably be a good feature to include in your model. So now they're going to do the same exact process, but this time they're going to use the feature called sex. And then, so are you female or male, and what is the what are your odds? Okay, so this is the, for female, 233 of them survived and 81 died. So from this graphic we can see that many males died as compared to as compared to the females, and many females survived as compared to the males. So there's something about, there's a correlation with dying or surviving based on the sex. Then they do the second, the third. So you can see each feature, we are just trying to see, okay, just by the basic illustrations, just the value counts. How does it relate to surviving or dying? And then by doing this, we are trying to, we understand our data, and we understand what we are trying to do. Okay, so embarked. So there's a feature called embarked, and embarked has percentage of embarked C, embarked D, and embarked is in 3 different classes: C, S, C, and Q. And we do the same exact process, and we see that for embarked, the people who are in S, most of the people in S died, and also I think looks like S was the biggest majority anyway. And also it's the same thing, like most of the people in S also survived, because in the end they had very many numbers in embarked S. But the percentages are like 34% of the people in S survived, 55% of C, survived, and then 33% survived. So this is just a simple process of trying to explore your data. You can do it in very many other ways. This is just at the very basic. This is using this thing called value counts, and in the end, getting the percentages. Okay? So then they go to the second process of data cleaning, feature selection, and feature engineering. So the pre-processing part, the pre-processing of the data is quite the crucial part. If we get the data set without cleaning it, most probably the results will not be good. So in this step, we will pre-process the training data set, and this will involve feature selection, data cleaning, and feature engineering. Okay, I will start with feature selection. As we see previously, P class, sex, age, and impact showed some relation with survival rate. So like that was the whole process of going through this. So we see the different features that have been provided to us, and we see, okay, do they have any relation to what we're trying to classify? In this case, did you survive or did you not survive? So thus, I will drop the remaining features except name, because it will give us, it will be useful in the further step in the cleaning process. So sometimes people drop features, but sometimes people are against it because you're dropping real data, and it could be helpful in one way or another. But since we're just doing a very baseline example, they've decided to drop all the other features. So you can see that the data set had passenger ID, cabin, ticket, fare, patch, and this stuff. So you can also do this process that we did above here to see, like, is there any relationship between passenger ID and if a person died or not, survived or not? Is there any relation between all these other ones? But for this person's example, they've seen that, okay, the ones that will help me are these ones, and then so I'm going to drop these ones. And this is not like, you should not be doing this in every use case. It's not like we recommend that you drop useless features. It's a whole lecture on feature selection, but for this, we're not going to delve deep. So what we're trying to predict, of course, is our Y, and you will see that most notation is important here. The big X is the features. The Y is going to, small y is what you're trying to predict. In this case, it is from this data frame, it is the survived column, okay? So we drop it, of course, in our features, and then, so the vectors of the label, that's the dependent variable, remove the dependent variable from the data frame X, and now this is how our data looks like. We have the P class, and then the different classes, 1, 2, 3, the name of the person, and then we have the sex, male, female, we have the age, and then the impact. So this is how our feature data frame looks like. So we can see from the display data form that X and that sex and impact are categorical features, and we have strings instead of numerical values. So we can see, like, when you go to train your model and you give it sex as male and female, it does not understand that is like it is represented as strings. So what the model needs to see is that, okay, we can just say this as maybe 1 and then the other one as 0. So this is what they're trying to explain here. We can see that from the display data frame that sex and impact are categorical features. They are categorical features because sex is you're either male or female, impact is you're either in 1, 2, or 3. But they're having strings instead of numerical values. We need to encode these strings into numerical data so the algorithm can perform its calculations, okay? So that's the whole point of encoding. So for the sex feature, we can use the label encoder class from sklearn preprocessing library. Another way to do this is by using get dummies from pandas. We will be using this to encode the impact feature, but first as impact has two nuns, we need to take care of these missing values. In this approach, I will use the S category because it's the most frequent data. After this, it is then possible that get dummies will get 3 categories. It will get 3 new columns, impact C, impact Q, and impact S, which are called dummy variables. They assign 0 or 1, indicating the membership of the category. The previous impact can be dropped from X, as it will not be needed anymore, and we can now concatenate the X variable the X data frame with the new embarked that will have 3 dummy variables. Finally, as the new dummy variables